The clay jar sits warm against the stone hearth, and inside it something is breathing. A slow, patient breathing. You can smell it before you see it. That bright, sour tang rising from the cracked lip of the vessel. A smell halfway between green apples and damp earth. The mother of the household leans close. She listens. There is a faint hiss, the soft pop of a bubble breaking the surface of a pale, living paste. Crushed barley, a splash of well water, the dust of grapes pressed last autumn, and time. That is all she added. By the third morning, the wild yeasts have multiplied into the millions. By the fourth, the dough swells like a sleeping animal, and when she finally tears it open, fresh from the hot stone, the steam carries something modern bakeries lost 2 centuries ago, a fermented bread that, according to a growing body of research, may support gut healing in ways no fresh loaf ever could. No daily feeding, no fragile starter, made once, eaten for weeks. This is educational content, not medical advice. Please speak with a qualified clinician before changing your diet, especially if you have a chronic condition or take medication. With that said, what unfolded in those Galilean kitchens nearly 2,000 years ago is one of the most fascinating intersections of scripture and science we have, and it deserves a careful look. The bread the people of the first century ate was almost nothing like what sits in a plastic bag on a modern shelf. It was alive. It carried wild microbes from the air, from the grain, from the hands that kneaded it, and it was bound up tightly with the religious life of the community. Leviticus 23:6 marks the Feast of Unleavened Bread, the 7 days when the Israelites were commanded to remove all leaven from their homes. Most modern readers treat this as pure symbolism, a story about purity, about hurry, about leaving Egypt. But scholars at institutions including Tufts University and the Weizmann Institute have noted something quietly remarkable. The yearly cycle of removing leaven and rebuilding the starter from wild airborne cultures may have functioned, in practical terms, as a microbial reset. Each spring, families purged their old fermentation cultures, then began again, capturing fresh strains from the new harvest, from the warming air, from the surfaces of freshly washed barley and emmer wheat. What they understood intuitively, we now know molecularly. The annual reset prevented the dominance of any single drifting culture, keeping the microbial community diverse, vigorous, and, in modern terms, functionally probiotic. Then comes 1 Corinthians 5:7 and 5:8, where Paul writes about old leaven and new, again, often read as metaphor for sin and renewal. Yet the practical layer beneath is striking. Paul was writing to a community in Corinth that lived and breathed the same fermentation habits as the Judean villages he had left behind. Bread was not a side dish in that world. It was, by some historical estimates, 60 to 70% of the daily caloric intake. So when Scripture spoke about leaven, the audience heard not only theology, but instruction. The bread you eat shapes the household you build, and the household you build shapes the body you live in. This wasn't symbolic ritual. This was applied medicine, and the research community has slowly begun catching up. What was actually happening inside those jars? The short answer is lactic acid fermentation, dominated by 2 organisms that researchers now identify again and again in traditional sourdough cultures from the Eastern Mediterranean. The first is Lactobacillus plantarum. The second is Lactobacillus brevis. Both are workhorses of the microbial world. They thrive on the natural sugars released as wild enzymes break down barley and wheat starches, and as they multiply, they produce lactic acid, acetic acid, carbon dioxide, and an entire pharmacy of secondary compounds whose names are unfamiliar but whose effects are not. Among them are exopolysaccharides, which are long sugar chains that may support the gut lining by feeding the beneficial bacteria already living there. There are also bioactive peptides released as gluten is partially digested by microbial enzymes. Peptides that research suggests may help calm certain inflammatory pathways. And there is phytase, an enzyme that quietly disarms phytic acid, the compound in raw grain that otherwise blocks the absorption of iron, zinc, magnesium, and calcium. That last point matters more than most people realize. A loaf of modern industrial bread, baked in under 2 hours from fast commercial yeast, retains the vast majority of its original phytic acid. A loaf fermented slowly in the 1st century style, sometimes for 24 to 36 hours, may show phytic acid reductions of around 70 to 90% in some studies published in the Journal of Agricultural and Food Chemistry. That is roughly 3 to 10 times more available mineral content from the very same grain. Same wheat, same water, different microbes, different outcome. You can begin to see why a population without supplements, without fortified cereals, without iron pills, could still maintain robust health on a bread-heavy diet, so long as the bread was alive. Now we come to the modern collapse. Sometime in the late 19th century, the commercial baking industry made a decision that, in hindsight, may have been one of the most consequential dietary shifts in human history. Wild fermentation, with its days of waiting and its unpredictable cultures, was replaced by a single isolated strain of Saccharomyces cerevisiae. Commercial baker's yeast. It rose dough in 90 minutes instead of 30 hours. It produced uniform loaves. It scaled into factories. And it skipped, almost entirely, the long lactic acid phase that had defined bread for the previous 4,000 years. The wild lactobacillus species were never invited to the party. Phytase had no time to work. Bioactive peptides were never released. Exopolysaccharides never formed. The bread looked the same. It tasted softer, and it carried almost none of the gut-supportive compounds the old bread did. Research from King's College London on the gut microbiome has documented, in study after study, that diets rich in fermented foods are associated with higher microbial diversity and lower markers of systemic inflammation. The reverse also appears true. Diets dominated by ultra-processed grain products, including most commercial breads, are associated with reduced microbial diversity. A 2021 paper from a Stanford research group, often cited in this space, found that participants who increased fermented food intake over 10 weeks showed measurable shifts in microbial diversity and a decrease in 19 inflammatory proteins, the compounds doing the heavy lifting. Among them, the short-chain fatty acids, particularly butyrate. Butyrate is produced when beneficial bacteria in the colon ferment dietary fibers, and it is the preferred fuel for the cells lining the colon itself. Healthy butyrate production is associated with a more resilient gut barrier, calmer immune signaling, and improved metabolic markers. The bacteria that thrive on fermented bread fibers, particularly the resistant starches, and the exopolysaccharides, are precisely the bacteria that produce butyrate most efficiently. So how did the ancient households make a bread that lasted weeks without daily maintenance? This is where the no-maintenance method comes alive, and where it differs from the modern sourdough hobby that has bloomed across social media. A modern sourdough starter is treated like a pet, fed daily, refrigerated, monitored. The first century approach was radically different and, frankly, easier. It worked on a principle the researcher Sandor Katz and others have called dry preservation. After the harvest, the household captured wild cultures by mixing crushed grain, water, and often a small amount of crushed grape skins or fig pulp into a clay jar. They let it ferment until it bubbled vigorously, usually 4 to 7 days. Then, and this is the critical step, they did not refrigerate it. They could not. They took a portion of the active culture, mixed it with extra flour until it formed a dry, crumbly meal, and let it air dry in the shade on a clean cloth. That dried fermentation meal could sit in a sealed jar for weeks, sometimes months, dormant but viable. When the household needed fresh bread, they took a small handful of the dry meal, mixed it with warm water and fresh flour, and within hours, the wild microbes woke up. They multiplied, the dough rose, and the household ate fermented bread without ever once feeding a fragile living starter. That dry meal carried the microbial memory of the household. Each family had its own. Each region had its own. The microbes inside were a fingerprint of the air, the water, the grain, and the hands of the people who lived there. Modern researchers at institutions including the Dublin Institute of Technology have documented that traditional dry preserved fermentation cultures from the Mediterranean basin retain viable lactobacillus and wild yeast populations for surprisingly long stretches, often 2 to 3 months at ambient temperature when properly dried. That is the no-maintenance secret. Not constant feeding, not refrigeration, dehydration into dormancy, then revival on demand. Why does this matter for a modern household? Because it lowers the friction to almost zero. You can make a fermentation meal once in a single afternoon and pull from it for the next 6 to 10 weeks of baking. Each loaf you bake from it carries the full microbial cargo: the Lactobacillus plantarum, the Lactobacillus brevis, the wild yeasts, the enzymes that liberate minerals from grain, the bioactive peptides, the exopolysaccharides that research suggests may support gut barrier function. You are not just eating bread, you are eating a fermented food that, in metabolic terms, behaves more like yogurt or kimchi than like the soft white slices most of us grew up on. And the gut axis context here is broader than most people realize. The gut microbiome communicates constantly with the rest of the body, with the immune system, since roughly 70% of immune tissue sits in and around the gut, with the brain through the vagus nerve and through neurotransmitters that gut bacteria help produce, with the metabolic system through short-chain fatty acids that influence how the liver and muscles handle glucose and fat. A 2019 review in the journal Nature Reviews Gastroenterology and Hepatology, looking across hundreds of studies, found that microbial diversity correlates with measurable differences in everything from inflammatory markers to mood-related neurotransmitter precursors. None of this means that bread alone fixes anything. It does not. But it suggests that one of the most boring, daily repeated foods in human history, the bread on the table, may quietly shape one of the most important biological communities in the body. There is also the question of why this matters now, more than at almost any other moment. Studies from the American Gut Project and similar large-scale microbiome surveys have shown that the average modern Western gut hosts noticeably fewer bacterial species than the guts of people living more traditional diets. The drop is not small. Some estimates place it in the range of 3 to 5 times fewer dominant species in heavy, ultra-processed eaters compared with people consuming traditional fermented foods regularly. That loss of diversity is associated in the research literature with a range of metabolic and inflammatory concerns. Rebuilding diversity is slow work, but research suggests that consistent intake of traditionally fermented foods is one of the more reliable dietary levers. A few practical notes before we close. The fermentation meal method does not require special grain. Whole wheat, emmer, einkorn, spelt, even barley will all support wild fermentation, though the microbial profile varies. Unchlorinated water matters, since chlorine inhibits the very microbes you are trying to cultivate. A small addition of organic grape skins, raisins, or fig fragments at the very first stage of capture provides a natural reservoir of wild yeasts and lactobacillus species clinging to the fruit surfaces. After the initial culture is active, the grape addition is no longer needed. The dry preservation step is the linchpin. Spread the active culture mixed with extra flour into a thin, crumbly layer on a clean cloth or parchment. Let it dry for 1 to 3 days in a cool, shaded spot until it crumbles easily, then store it sealed away from light and heat. Pull from it as you need it. Refresh the entire meal once a season if you bake heavily, or once a year in the Leviticus tradition. A yearly reset that, as the researchers noted, may have quietly maintained microbial diversity in those ancient households for generations. The bread that results will not look like supermarket bread. It will be denser, darker in places, slightly tangy, and deeply aromatic. It will keep on the counter for days without molding, because the lactic acid produced during fermentation is naturally inhibitory to mold spores. It will not be the bread of factories, it will be the bread of households. The same bread, in essence, that sat on the table when Paul wrote his letters, when the families of first-century Galilee gathered after sundown, when entire communities ate the same alive food and lived, on average, with a gut microbial diversity we can now only attempt to rebuild. None of this is a prescription. It is not a cure. It is not a treatment for any condition, and anyone with celiac disease, severe gluten sensitivity, or any chronic illness should speak with a qualified clinician before adopting any new dietary practice. What the research does suggest, carefully and consistently, is that the way bread was made for most of human history carried compounds and microbial communities that modern industrial bread does not, and that the no-maintenance method, born of necessity in a world without refrigeration, may be one of the most elegant solutions ever devised for keeping a fermented food alive in a household on a casual, sustainable rhythm. So the question becomes simple, and it is yours to answer. Which step of this old method will you try first? Will it be the initial capture, mixing crushed grain with water and a handful of grape skins in a clean jar and letting the wild microbes find their way in? Or will it be the dry preservation step, taking an active culture and turning it into a crumbly, shelf-stable meal that lives quietly in your pantry, ready whenever you are? Maybe you already have a starter going and you want to try the seasonal reset, drying down what you have, and beginning again with fresh air and fresh grain. Whichever step calls to you, drop it in the comments below and tell us what grain you are working with, what region you are in, what wild microbes might be drifting in your kitchen air right now. The more we share these old methods, the more we recover something that was lost in the rush to industrial speed. Thank you for being here, for thinking carefully about what you eat, and for honoring the slow, patient wisdom of a household 2,000 years ago that already knew in its bones that the food you make once can feed you for far longer than you expect.